What you got for us, Ranty?
You asked for
Brilliant.
the wind farm images,
Yes.
so I've got a couple of them up.
So yeah, so this is what we're presented with and can be measured mathematically in terms of how much curvature we're seeing. So each of these wind turbines is disappearing in boat terminology, hull first. That's what we've got. And you can measure out these distances from the nearest one at about 11 miles to the furthest one, which is about 13 miles. And you can do the curve calcs on it and say how much should it be going according to globe science over the curve of the Earth. And this is what you end up with. The main problem being that if it's actually conforming to a curve, therefore what you're having visually demonstrated to you is a curve, then they must be curving, right? They must be built on a curve. The problem is they're not. They're not built on a curve at all. They're absolutely flat as a pancake, all of them. So what we've got in terms of this image is various different coloured lines, red, yellow, blue and white, going through all the different... Hi Mark, how you doing?
Hello, folks. How are we?
Good to have you. So all the different depths. So again, this is the first line, I think, is the red line. Is that correct, Ranty?
Yep, the nearest, the one on the right. So that would be the first one, the image we were looking at. These ones.
So
these are
this
the red lines.
Yeah. So this row of wind turbines, if you were to go further left in this image, you'd have another row, and then further left still, you'd have another row, and that's what we're seeing in this image. Them going further and further back. And the same effect happening. Obviously, the angular size gets smaller at distance. It's the effect of perspective. So therefore, the ones in the background are smaller. But ultimately speaking, what you see at 11 to 13 miles and is claimed to be curving around the Earth isn't curving around anything. It's absolutely flat as a pancake when you look side on to this. So this was something that I asked Ranty to see if he had actually got in his myriad of pictures that he's got on his hard drive. Because it was one of the first things I covered on Flat Earth UK. So Fake Spaceman in Space and myself did exactly this demonstration, but we didn't have it anywhere near as cool as Ranty's got it because it's got real world images. So what we did was just showed it in CAD. You know, this is a slightly further angle, so this is looking down the back row from the further distance. So again, we've still got 11 miles at the nearest and 13 miles at the furthest, but we're at a slightly, you know, a more acute angle, or more obtuse angle, sorry. So you can see them going down the line and then actually measure how much the curve calcs say they're dropping behind the curve at 13 miles. And they absolutely are, according to your maths, going around a curve. And it's visible at this distance.
Yeah, I just want to add to that. When you look at it from behind, what was the distance to the turbines from behind, Ranty?
Which ones are you talking about?
You know, the picture that you started with, the one that's on the right there. No, not that one. That's from that you're looking side on there. Yeah. What's the distance to the first turbine?
11 miles, just over.
So there's 11 miles. That's this turbine here.
Sure. So what's that doing from that picture? What that's doing is giving you the lack of exponential curvature. So from the side angle, you could argue that, well, yeah, you're not going to see any curvature left to right. But when you go behind them at 11 miles, there's an exponential buildup of curvature that's dropping away from you in the picture. So on the ball earth model, it would be the case that from when you're looking at them when they go left to right and you're looking at them like front on, yeah, you're not going to see any curvature left to right. But when you stood behind it from 11 miles away, there's an exponential drop that's missing there. It shouldn't be going down in a straight line. It should be exponentially dropping, and 11 miles is a good distance to show that it's not doing it.
And what we actually see is we actually can put a straight line through these turbines here from a distance of 11.5 to 13.5 miles. So let's get the right image up, which is this one. This is the line going through the turbines of the left-hand wind turbines.
I just want to give that clarity. Sorry. So what this image of, although they look like they're next to each other, you're looking down the line. So you're looking from front to back, even though they look like they're next to each other. This is what you're looking at from front to back, just a slightly greater angle. So they look like they're next to each other. Obviously, the blades aren't going to smash into each other. They're not next to each other. You're looking down the line from 11 to 13 miles. Sorry.
Yeah, so you're looking at this one, then that one, then this, and this. Okay. So as we're looking at these ones here, they're all going through the center of the hub. Right, this line is going through the center of the hub. Now, if we put that on a perspective and put a line in, we put the hard horizon at the bottom and we're doing this perspectively, essentially it matches pretty much the curvature calcs. So the curvature calcs say that the hub should disappear at 10.3 miles past the first turbine. So that's probably around about, what, 22 miles or so. The hub should be gone. But on this diagram here, it says basically 11 miles past the first turbine, they should disappear due to perspective and angular change. So they're getting smaller as they're going further away in the distance. So what you have to try and judge yourself is it getting smaller and looking like it's going over a curve, or is it just changing due to perspective on here? Because this one is obviously looking smaller than this one, but you put a line through them, and if it was going over a curve, the curve would be arced slightly. It would be arced, but it's completely straight.
Yeah, it's because it's a factor of the 8 inches per mile squared that leaves you with this exponential drop at distance. So when you start looking at stuff going between 11 to 13 miles, of course you can see the curve, it gets exponentially more because it's a ball. So yeah, the further out you look, the more ball you see. It's like, well, if that's true, then this must be conforming to that ball. And it isn't.
Yeah. Now remember, 11 to 13 miles, that's not that different to what Soundly shows on his pylons and bridge Pontchartrain stuff. So what Soundly's showing is claimed to be the curvature of the Earth, which we all realise is not. But if it was the curvature of the Earth, we should be seeing the same thing here. Not on this picture where it's left to right curvature, because it isn't enough of a span. But from behind, when you're looking at the same turbines, but from behind, it's 11 miles away. There is built up and accumulated and an exponential curve drop that is required to be there by virtue of that fact of it being 11 miles. And as you can see, there is none. Absolutely none. There is no exponential drop.
The ball Earth bullshit is just bullshit. You know, just because something's 13 miles away doesn't mean it starts to go around the curve of the Earth and you can see this exponential drop, because that's nonsense. You know, that exponential factor would have to be seen in the side elevation. You know, if the Earth is a ball, and it isn't a ball, it's flat.
Yeah, but what the points I was making was that there's no exponential drop on the left to right curvature picture, so it would be minuscule and they wouldn't be able to detect it. That's their argument. But on that picture, where it's taken from behind, it should be exponentially seen because it's 11 miles away. There is a build-up of 11 miles of curvature before you get to the first turbine. And by the last turbine, there should be a prominent, pronounced, and obvious curve. You should see it.
Yeah, and all we see is the effects of perspective.
Yeah.
Which coincidentally match the maths for drop. What do you know?
Yeah. So are you suggesting, Nathan, that the curve calculations are simply a calculation for perspective?
Yeah, they are. And they've incorporated refraction. Simple. They've basically observed how the world works and then co-opted the maths to work with the sphere to convince people that when you look out beyond 10 miles, you see this exponentially increasing drop of things falling behind a curve. And that's impossible. You can't have that happening unless things physically are curving around the Earth. And they're not.